In this video, we will look into different segmentation capabilities available within ACI. ACI follows a zero trust model, that is a whitelist policy model, which means all communications between endpoints or endpoint groups are denied by default. Thus, it supports a stateless line rate distributed firewall within the fabric. If you want communication between EPGs, then we will need to specifically allow them. This policy is location independent, meaning it follows the workload within the fabrics. All endpoints within an EPG communicate with each other by default. ACI supports segmenting the workloads further within the EPG itself. It's called intra-EPG isolation. With this, endpoints within an EPG won't be able to communicate between each other, but can communicate outside the EPG, like to any common services, etc. This provides enhanced security for east-west traffic and is hypervisor independent. That is, it is supported across all the hypervisors, be it VMware or Hyper-V, etc. The third type of segmentation that ACI supports is attribute-based segmentation of workloads. The attributes can be network-based attributes like IP address, MAC address, or VM-based attributes like VM name, OS type, etc. This way, we can quarantine a rogue or a vulnerable virtual machine based on its attributes and provide granular control within the data center. All this can be done across hypervisor domains, again, be it VMware or be it Hyper-V or KVM. With the combination of intra-EPG isolation and attribute-based segmentation, ACI provides a very granular level of segmentation capabilities that is needed in today's data center. So let's now quickly jump onto a demo and see all this using VMware DVS. So I have already an ACI fabric which is already integrated to a VMM domain, which is using the ACI DVS, that is VMware Virtual Distributed Switch. So let's quickly check that out. So this is the DVS, and this is the integration that I already have within the fabric, and this is using the VMware distribution switch. So let's quickly create a tenant, and let's call this tenant useg tenant for microsegmentation. Just get a simple tenant useg VRF. So let's create a single BD. Create a single bridge domain. I'll just call it BD1. And I'll just select the VRF to be useg VRF. I'll go to next. Let's give it one subnet, which is 1.1.1.254/24. Keep it as private. Let me add another subnet as well, just to the same BD. So we're kept at two BDs. Let's create an application profile. Call it useg ANP. Let's use our drag and drop capabilities of ACI to define those. So let's create a single EPG called EPG1. Make it part of useg BD1. I'm going to create another EPG, just called EPG2. Make it part of the same BD. Let's add our VMware domain. So DVS. So I'm not choosing anything. I'm just going to use VLAN. I'm just going to say OK. So DVS. And let's say submit. Let's go to our application EPGs. And let's allow microsegmentation as well. This is by default false. I'll allow microsegmentation and just change this to both immediate. Okay, and similarly I'll do it for EPG2. So I have three VMs within my vCenter. These are the three VMs, VM1, VM2 and Win7. So we'll put VM1 and VM7 into EPG1 and VM2 into EPG2. So right now they are part of the quarantine EPGs. So, and similarly if you look at VM2, that's also part of a quarantine port group, and then Win7 is also part of the default quarantine port group. But since we have created the EPGs, those distributed port groups have appeared into the vCenter. So let's quickly assign them. So I'll put VM1 into useg EPG1, and I'll put Win7 into useg EPG1 as well. Okay, and I'll put VM2 into useg EPG2. Remember that we didn't have any contracts defined between EPG1 and EPG2, so that means by default the communication should not happen between workloads that are part of EPG1 and EPG2. Let's quickly check that. But the workloads within EPG1, that is the VM1 and Win7, should be able to communicate to each other. So let's quickly log on to VM1, and this is my VM1. Let's quickly check the IP address. Okay, it's 11. So let's just quickly check whether it can equal to ping the gateway. So it can ping the gateway. Similarly, let's check what's the IP address of Windows 7. So let's quickly check this. So it's 14. So let's check if it's able to ping the gateway. And it is able to ping the gateway. Let's quickly check if it is able to ping the other workload in the same EPG. And it is able to ping VM2, on the other hand, was part of EPG2. So quickly check if what's the config here. So this is 22211. So let's quickly check if it's able to ping the gateway. It's able to ping the gateway, but as you can see, this will not be able to ping the other VM1 machine, nor it will be able to ping the Windows machine, which is part of the EPG1. So let's quickly define a contract and see how this communication can be enabled first. So this is the by default the first level of segmentation that ACI offers us. It's basically a stateless firewall of any EPGs which are part of the different any workloads which are part of the different EPGs will not be able to communicate unless you provide specific contracts between them. It doesn't matter whether they are part of the same IP address pool or not, but as long as they are part of different EPGs, a specific contract has to be defined. So let's go ahead and define our contract. So EPG1 to EPG2. I'll just make it all. This between EPG1 and EPG2. I'll just call it all. And I'll just click OK. Just do a submit. So this contract is there between EPG1 and EPG2, and let's quickly check now if we are able to see communication. So yes, this is VM2, and VM2 is now able to reach 1.1.14, which is the Windows machine, and it is also able to reach the other VM1 machine. So communication exists between VM1 and VM2, which are part of the different EPGs. The second level of segmentation that ACI offers is something called as Intra-EPG isolation. So let's just first quickly check that within EPG1 we can find that there is a VM1 endpoint and a Win7 endpoint. Both are 1.1.11 and 1.1.14, whereas in EPG2 we can identify a workload which is 2.2.11, which was VM2. The second level of isolation that I talked about was intra-EPG isolation. So let's quickly do that. So within intra-EPG isolation, what happens is within an EPG, I'll ensure that there is no communication exists between the same workloads, which are part of the same subnets as well, but it will still be able to reach the EPG2, which is part of the other EPG, because we have a contract existing between the same. So let's quickly define that. Defining intra-EPG isolation is very simple. You just need to basically go and enforce the intra-EPG isolation within the EPG policy. So let's go ahead and do that. Just throws up a warning and just click submit. So let's quickly jump on to VM1, and this is VM1, and let's quickly see if it still is able to ping the gateway, but it will not be able to ping the Windows machine. Similarly, let's check the Windows machine as well. So Windows machine has started timing out. But on the other hand, let's quickly check if it's able to ping our workload in EPG2, which is the VM2. It's still able to ping. So that was it. So it was basically intra-EPG isolation, but within an EPG, we can still configure intra-EPG isolation to isolate workloads within an EPG, but it still be able to contact to workloads outside the EPG or to other common services as well. So this was the second type of segmentation that ACI offers. Now what we'll do is basically create an attribute-based microsegmentation. So what I will do is basically drag in. I will identify the Windows machine as part of a VM attribute, and then try to associate to a microsegmented EPG. So let's quickly do that. So define a new microsegmented EPG. You need to go to a microsegment EPG and create a EPG, microsegmented EPG. So I'll just call it useg1. Here again, within the useg EPG as well, you can do an intra-EPG isolation, but for this demo, I'm not going to do that. It should be part of the same useg PD1. And now you have to define useg attributes. Now these attributes are either IP address or MAC address attributes, which are network-based attributes, or we'll use the VM-based attribute to define the microsegmented EPG. So let's define museg VM. I'll just call it museg VM. I'll say VM name. Rather than that, we'll just say operating system equals, I'll say Windows 7. Okay. So I've created the CPG. Okay, and I'll just associate the virtual VMM domain that the Windows 7 was part of. At the moment I associate the virtual domain to this microsegmented EPG, it will identify that the Windows 7 machine based on the VM attribute, and it will actually move the Windows 7 from EPG1 to the microsegmented EPG. So let's quickly check that. We'll do it DVS, just make it there and be auto. I'll just say update, and I'll just say finish. The moment you do that, you can now see that there's a museg1 micro EPG, and if I go to the operational tab, the Windows 7 machine has just now moved from EPG1 to Windows 7. Just to check it again, we'll go to EPG1. If you see in the operational tab, there's no more a Windows 7 machine in the EPG1. It has actually gone to the museg EPG. The moment it has gone to museg EPG, now this is a different EPG altogether. So the contract that was existing between EPG1 and EPG2 will not be able to provide communication from museg EPG to the EPG2. So EPG2 should not be able to reach both of this. So it's still not able to connect to EPG1. Now it is, though the contract is existing between EPG1 and EPG2, it would still not be able to reach the workload in the EPG2 as well, because there's no contract existing between the museg EPG and the EPG2. So let's try that, and this is also blocked. Just to view it in a So if you look at this, so the music EPG does not have any contract, and that's why the moment the workload moves to the music EPG, the communication between the workload that has moved to music EPG is fully isolated. So the workload has fully isolated. So this is a very great feature of ACI itself, because if we can actually use this to identify if there is any rogue machine or any rogue machine that affects a particular operating system, we can assign an attribute based EPG and then move the workload automatically from the base EPG to the microsegmented EPG and isolate the workload, vulnerable workload for that matter, completely without doing any configuration changes in the VMware. And this, though I demonstrated in what VMware really has, it is quite possible even with Microsoft Hyper-V as well. So that's it. That concludes the demonstration of microsegmentation and different types of segmentation available in ACI. Thanks for watching.